The pH of the mixture. Okay, today we're going to find out the pH of the mixture of strong acids or strong bases or an acid and a base and an acid and a base. You understand?
All right. Yes.
So we are talking about the pH of the mixture of strong acid or strong base. That's what we are supposed to find out today. Now, it's very simple here. What is happening right here? Just see. Let's suppose that, see, there are two formulas. The point is, when we are mixing the two liquids, when we are mixing the two liquids of the same type, okay, of the same type,
Yes.
that means what? When we are mixing the two liquids of the same type, what exactly does that mean? You tell me. It means that, either both of them should be acids, both or more than two could be there. So either both of them are acids or both of them are bases. Now, you know that, when both of them are bases, what exactly does that mean? Tell me. When both of them are bases, so the final mixture shall also be a base. The final mixture should also be a base.
Right.
When both of them are acids, the final mixture must also be an acid. Yes or no? And for acids,
Yes.
you remember, we calculate pH. But for bases, if you remember, we calculated pOH first and then we applied the formula pH plus pOH is equals to 14. Do you understand? So when we are talking about this particular part, always remember when we are mixing the two substances, we always have to calculate a new concentration. We always have to calculate a new concentration. Alright. So there is a certain formula. So now for the first time, I am discussing when we are mixing the liquids of the same type. Either both of them are acids or both of them are bases. So what is the formula? The formula is molarity nu. Molarity nu is also read as concentration nu. Molarity nu is also read as concentration nu. Are you understanding?
Yeah.
So that is going to be what? Tell me. That is going to be M1V1 plus M2V2 over V1 plus V2. Alright. And specifically if we are finding out the new concentration of H plus or the new concentration of OH negative, so then we multiply it with what? We multiply it with N1, M1V1 and N2, M2V2. Are you understanding my point? That means what?
Hello.
Yeah. That means that, if you're finding out the concentration of H plus or if you're finding out the concentration of OH negative, what are you going to do in that? You have to see that how many H plus ions are there in a particular acid. So let's suppose we are talking about H2SO4. So you know now that H2SO4 is going to give you H plus ions, 2 ions. So this is going to be N1 for me. N1 is going to be the number of H plus ions N1 is going to be the number of H plus ions present in the solution. Are you understanding my point?
Yes.
So I could make out this formula as N1 M1 V1 plus N2 M2 V2 upon V1 plus V2. Now, what is this formula? N1 M1 V1 plus N2 M2 V2 upon V1 plus V2. Are you understanding? So this is going to be my new molarity formula. Always remember, whenever you are mixing the two substances, this formula can be elaborated up till 3 and 4 and 5, as much as you feel. Do you understand my
Yeah.
point? So this is the concept. So what exactly is the concept? It says, so new concentration you have to find out. Now sometimes we do not really need the concentration. Now, when do we have to calculate the concentration of H plus? Understand. When do we have to calculate the concentration of H plus? When there are two different acids. When there are two different acids. Okay? When there are two different acids.
Yeah.
Then we have to calculate the concentration of H plus. But if both the acids are same, then also we have to calculate the new concentration, no doubt about that. But in that scenario, the N1 and N2 shall remain same. I'll give you the example, you understand. See, why this has come up, understand. When I say there is this beaker, and in this beaker, I am mixing what? I am mixing 500 ml of 0.1 molar H2SO4. Does that make sense? And from the other side, I am mixing 400 milliliters of, or I'm mixing 1500 milliliters of HCl, which is 0.7 molar. So I have given you the molarity. That means, ma'am, 0.7 moles per liter and zero point 0.1 moles per liter. That's what 0.1 molar means, isn't it? Do you understand my point? So, what is the concept? Tell me, what is the concept? The concept is that when we have zero point 0.1 moles per liter and I have 0.7 moles per liter right here. What do you understand? We have it right here. Tell me. That, ma'am, for H2SO4 that you're adding into the beaker, you say that it is 0.1 moles in 1 liter. What is 1 liter? 1000 ml. Are you understanding my point? So 1000 ml of
Yeah.
solution contains 0.1 moles of H2SO4. So don't you think 500 ml should contain how much? 0.1 over half of it? Because if you half both sides, isn't it? So basically what I'm trying to explain you is this. Just calculate one thing. We have, so in 1 ml, how many moles of H2SO4 would you have? 0.1 over 1000. Because if I have to make divided by 1000 right here and divided by 1000 right here, isn't it?
Yeah.
So we would have what? 0.1 into 10 raised to power minus 3. These many moles I will have in 1 ml. So how many moles do you think I will have in 500 ml? Into 500. So 5 into 500 into 0.1 into 10 raised to power minus 3 becomes over 1000. So two zeros cancel here. So you will have what? You will have 5 into 0.01. That would be the total moles in 500 ml. So thereby it shall be 0.05 moles in 500 ml. Are you understanding my point? Right.
Right.
So that is the concept. That is the concept. So my point here is that I have 0.05 moles of H2SO4 coming from this solution because I am adding only half of it. No, I'm not adding full 1 liter. If I would have added 1 full liter, then it would have been 0.1 moles of H2SO4 coming. from this side into the beaker. Do you understand my point?
Yeah.
So what I'm trying to tell you is that if I have this particular part, just understand what exactly is happening. That if I have 0.1 moles per liter, okay, if I have 0.1 moles per liter, what do you think I will have? Only half of the liter I'm adding. So that means half of the moles. So I am getting 0.05 mole of H2SO4. Okay, that's fine. And 1 mole of H2SO4, you tell me, gives me 2H plus, isn't it? So if
Yes.
0.05 mole shall give me how much? 2 times 0.05, which is going to be 10, 0.1, isn't it?
Yeah.
And if that is going to be 0.1, what do you understand from here? Tell me. If that is going to be 0.1, what do you understand from here? Tell me. We have 0.1 right here. So that means, ma'am, I have 0.1 H plus coming from 0.05 moles of H2SO4. What does that mean? You tell me. That means that, ma'am, what am I going to do? I'm going to say that from this solution, I'm having 0.1 moles of H plus. Do you understand what I'm doing? So I have now
Yes.
calculated how many moles of H plus I will be getting from H2SO4. Are you understanding my point? Do you understand? Now, similarly, if I talk about the same beaker, but from here I am having 1500 ml of HCl, which is zero point 0.5 molar, 0.7 molar, sorry, 0.7 molar. So, what will I say? That, ma'am, 0.7 molar means what? 0.7 moles per liter, isn't it?
Yeah.
And if I have 0.7 moles per liter, that means 1000 ml. For 1000 ml, I have 0.7 moles in the solution. That's what I'm saying. That if I have a 1000 ml solution, all right, in the 1000 ml solution, what do you think I would have? 0.7 moles of HCl, isn't it? So, in 1 ml solution, I will have 0.7 moles over 1000, isn't it?
Yeah.
And so, in 1500 ml, I will have 0.7 over 1000 into 1500. So, two zeros shall cancel two zeros, and I will have 7 times 5, 35, and 10. So, I will have 10.5 over 10. So, it is going to be 1.05 moles of HCl. Do you understand my point?
Right. Yes.
So, if I have 1.05 moles of HCl, just tell me, when HCl breaks down, don't you think it is going to give me H plus ions and Cl negative ions? So 1 mole of H plus ions will give me 1 mole of H plus and 1 mole of Cl negative. Are you understanding? Just tell me, isn't it? 1 mole
Yeah.
of HCl shall give me 1 mole of H plus and 1 mole of Cl negative, isn't it? What does that mean? That, ma'am, 1.05 moles of HCl shall give me 1.05 moles of H plus and 1.05 moles of Cl negative. I am concerned with only H plus. Why am I concerned with only H plus? Because I have to calculate the pH. So do you remember that, from this side I was adding 500 ml of H2SO4, which was 0.1 molar. So I got to have 0.1 molar. So I got to have how many moles? I got to have 0.1 moles. 0.1 moles of H plus coming here because I calculated. And from here
Right.
I'm going to get 1.05 moles of H plus. So just tell me, how many total moles of H plus do I have right here? So total H plus if I have in this beaker, that would be 1.05 plus 0.10. So that is going to be 1.15, isn't it?
Yeah.
And if that is going to be 1.15, what do you think it would be? Tell me. 1.15, what would that be? Tell me. I have these many total moles of H plus, but in how much liters? 1500 ml solution is coming from side B and 500 ml is coming from side A. So in 1500 plus 500 ml, that means in 2000 ml solution. Yes or no?
Right. Yeah.
That means what? That means what? That means that in 2000 ml solution, I will have, in 2000 ml solution, I will have what? In 2000 ml solution, I have 1.15 moles of H plus. Do you understand this point?
Yes.
Any doubts up till now? Tell me.
No. No doubt.
Right? So when I'm talking about this particular part, just tell me one thing. Just tell me one thing. If I'm talking about this part, what is the new concentration of H plus? Concentration means per liter or per 1000 ml. So I would say that, ma'am, in 2 liters solution, now the new solution that is being formed is 2000 liters, 2000 ml. So I would say 2000 ml is 2 liters. So I would say in 2 liter solution, we have 1.15 moles of H plus. So thereby, in 1 liter solution, what is going to happen? In 1 liter solution, it is going to be 1.15 over 2, isn't it? Moles per liter. So this is going to be my new H plus ion concentration. Now, see, understand, whatever I have done up till now, I am trying to, find out how many H plus is coming from one beaker, how much H plus is coming from another beaker, and then dividing it with the total volume. That's what this new formula gives you. So molarity new would give me what? Straight away N1 M1 V1 plus N2 M2 V2 over V1 plus V2. So whatever I have done up till now right here, that the formula is doing it very simply. All you have to do, just write down the molarity, just write down the volume, multiply them, write down N, the number of H plus ions the first acid is giving you, and similarly for the other, divided with the total volume. That's what you see, understand we are doing? We are dividing it with the total volume, isn't it, Shruti?
Yes.
What is the basic concept here? The basic concept here would be, the basic concept here would be that this is going to be my new concentration of H plus ions, and then I'm going to calculate the pH. And what is pH of the solution? pH of the solution is going to be minus times log of H plus ions new concentration, because you are calculating the pH for the solution. So that comes out to be minus times log of 1.15 over 2. Do you understand my point?
Yes.
So minus times log of A over B becomes what? Log A over B becomes what? Log A minus log B. So log 1.15 minus log 2, isn't it? So if you bring this minus inside, it becomes minus log of 1.15 plus log 2. So log 2 minus log of 1.15, and simply solve this. So log 2 we know as 0.3010 minus log 1.15. What would that be? You have to calculate that. So using the calculator, you can calculate log 1.15 and simply solve this to get my value of pH of the solution. Understood or not?
Yes.
Any doubts up till now? Calculate the pH of 0.1 molar HNO3 600 ml, 0.001 molar H2SO4, 800 ml, and H3PO4. Assume H3PO4 to be a strong acid, though it is a weak acid. But I'm saying just assume it for a while that it is a strong acid. And zero point 0.6 molar, 0.06 molar, 200 ml. So you have to calculate the pH of this and this. Alright, this mixture's pH we are supposed to calculate. So just write down the formula. So that means when it talks about the pH of the mixture, you have to calculate the new molarity. So new molarity should be what? N1M1V1 plus N2M2V2 plus N3M3V3 over V1 plus V2 plus V3, isn't it?
Yes.
So new molarity shall be what? Just tell me. So for the first acid, what is N1? There is only one H in the acid, so I would say 1. What is the new molarity? Molarity is 0.1 into what is the volume? 600. I choose not to convert the volume into liters. So I am keeping the volume in milliliters everywhere. Plus N2. N2 is what? Number of H plus ions in the H2SO4. So 2. Molarity is going to be 0.001 and volume shall be 800. Yes or no?
Yes.
Plus, what is N3? N3 is H3PO4 and we have 3H plus it is going to give me. So 3 into molarity is 0.06 and volume is
Right.
200 over V1 plus V2 plus V3. So V1 is 600 plus V2 is 800 plus V3 is 200. And this solving this will give me new concentration. Are you understanding? So this formula eases out so many things that we have to, sort of understand. So this is going to be the new concentration. So this is going to give me 60 plus this is going to give me 1600 into this. So it's going to give me 1.6 because two zeros brings this right here. And plus this is going to give me 12 times 3, 36 over 1600. This is going to be my new concentration. So for me it is going to become 97.6 over 1600. And you can divide this value and tell me the new concentration. 0.57. So this is my
Right.
new concentration. Of what? This is my new concentration of H plus.
Yes.
How do I know this is the new concentration of H plus? Because I have multiplied everywhere N1. And N1 is the number of H plus ions from every acid. Are you understanding?
Yes.
So when I have this N1 value, H plus ion, so I know that this is a new H plus ion concentration. New H plus ion concentration, isn't it? And when this is a new
Right.
H plus ion concentration, what exactly do you think it means? What exactly do you think it means? Tell me. It means new pH of the mixture. New pH of the mixture. That is equals to minus times log of new concentration. And that shall be equals to what? Minus times log of what is the new concentration? 0.057. Isn't it? And that is going to become minus log of, I can write it down as 57 over 1000. Yes or no?
Yes.
So that is going to become what? Minus times log of 57 minus log of 1000. And minus you bring down inside, that becomes log 1000 minus log 57. So log 1000 is going to become what? Log 10 cube minus log 57. So that is going to become 3 times log 10 minus log 57. And log 10 is 1. So basically 3 minus log 57. If you can just calculate log 57 and subtract, and that is a new pH for the mixture. Understood or not?
Yes.
So the new pH of the mixture would be 3 minus log 57. Understood. Any doubts in this?
No.
Are you sure?
Yes.
Right? That is how we are supposed to calculate the mixture's pH. And which mixture's pH? Of strong acids or strong bases. But this formula is applicable when all of them are acids or all of them are bases. Now, similarly, solve another question. If I calculate
Okay.
the pH of the mixture of 0.2 molar CaOH whole twice, 500 ml, 0.001 molar NaOH, 600 ml, 0.2 molar ALOH whole size, 900 ml, and 0.2 molar shall be 0.02 molar. This. So now, first of all, I can see that this is a solution of all the bases. And when this is a solution of all the bases, what would that mean? Tell me. When this is a solution of all the bases, what would that mean? It would mean that pH is going to be what? So first of all, I'm not going to calculate pH. I'm going to calculate pOH because for bases, we always calculate pOH. So I'm going to apply the new OH ion concentration. So I'm going to say square bracket OH new. So that would be again the same thing N1 M1 V1 plus N2 M2 V2 plus N3 M3 V3 over V1 plus V2 plus V3, isn't it? So what is N1? My first base is COH whole twice whose N1 is 2. M1 is 0.2 and volume is 500. Plus N2 is going to be 1. Molarity is going to be 0.001 and volume is going to be 600. N3 is going to be 3. Molarity is going to be 0.02 and volume is going to be 900 divided by 500 plus 600 plus 900. Am I right? And this is going to be OH new. And just solve this. So I'm going to get 20, 20 into 5, 100, 100, 200. Plus I'm going to get 0.6 and I'm going to get 18,354 over it is going to be 1900. So this is going to be my new OH ion concentration and that would be 254.6 over 1900. So this is going to be my new OH ion concentration. Are you understanding my point? Just calculate that for me. How much would that be? Okay. So that is going to be 0.134 moles per liter. Are you understanding my point? That is my new OH ion concentration. But if I know the OH ion concentration 0.134
Yep.
moles per liter. So POH shall be what? POH shall be minus times log of OH. So minus times log of 0.134. So that would be what? Minus times log of 134 over 1000 and minus times log of 134 minus log of 1000. So if you take out the minus sign inside, it becomes log 1000 minus log 134. Log 1000 is 3. 3 minus log 134 is going to be this. Understood or not? This is going to be POH. Are you understanding, Shruti?
Yes.
Whatever is this answer going to be, I'm going to put it into this formula. pH plus POH equals to 14. So what is pH? I do not know. What is pOH? 3 minus log 134, and that is going to be 14. So pH is going to be 14 minus 3 plus log 134. So that is going to be 11 plus log 134. Yes or no? And whatever is the answer, just add it up to this value, and this is going to be the pH, and definitely the pH has to come out to be greater than 14. Are you understanding my point?
Yes.
Right? So that is the question. Any doubt in this?
Okay.
Simple. Understood or not?
Yes.